Good morning, my YouTube viewers. Crystal here. It is early in the morning, so I've had to turn the camera off because I'm not really wearing proper attire to be giving a presentation. But I just found that I think it works out better for me if I give my videos early in the morning because I've had a good night's sleep. I can think about what I want to say and I can give my presentation. Whereas if I give my videos like in the afternoon or in the evening when I've been working all day long, um, what might happen is I might be tired and I might not do as good a job. So that's why I've had to turn my camera off because it's too early in the morning for me to be seen. What I wanted to do today is I wanted to give you a presentation on the Linnerrud dataset. This is a dataset that is in the sklearn library, and it's a multi-target or multi-label dataset, which is what I wanted to do. And so I wanted to analyze this dataset. So, as I said, it's in the sklearn library. So if you look under toy datasets, you can actually find the dataset if you wanted to experiment with it. I don't know why they call it a toy dataset, but that's just what they call it. Maybe it's because it's a small dataset, it's a small dataset for someone to play around with. And so since you're playing around with it, they call it a toy. I'm not sure exactly. I don't know what they were thinking when they did that. So I wrote my program in Google Colab, which is a free online Jupyter notebook. I did like Google Colab, but I found out they don't have the most current versions of their libraries installed on the platform. And when I found that out, it disappointed me because you would think that if they're a free online Jupyter notebook, you would think that they would want to have the most current versions of their library installed, but I guess they don't. I even sent them an email and asked them if they would install it, and they haven't done it. And the reason why is because when you're working with the toy data sets in the version number 23.0.23, they have an as frame function, and then what the as frame function will do is that will present the data in a data frame, which is what we want to see. We want to see data frames. But because they have not presented the data in a data frame, then I have to manipulate it to turn it into a data frame. So you can, on Google Colab, if you want to, you can install the most current version of the data set into Google Colab if you want, but then you're going to have to install that version every single time you use it. So I just decided that I didn't want to do that, so I would just use the version of sklearn that they have on their system. When I wrote my program and executed it and saved it, I saved it onto a GitHub repository, and I'm going to be making a blog post on this code review. And when I make a blog post on the code review, I will actually give you a link to my GitHub repository so you can look at the code if you want to. So if you want to get the code, then what you need to do is you need to actually read the blog post for Medium Publications that I'm going to be making. The video that I make will probably be the one right after this one, because whenever I make a blog post, I make a video to let you know that I've made a blog post, and then in the description box I give the link to the Medium blog post so you can read the blog post and get the link to the GitHub repository. So without further ado, we'll go ahead and start with this code review. This is about the Linnerrud dataset. It said the Linnerrud dataset is a multi-output regression dataset. It consists of 3 exercise data and 3 physiological target variables collected from 20 middle-aged men in a fitness club. So the physiological data is weight, waist, pulse, and the exercise is chin sit-ups and jumps. And so it's only got 20 examples in it. So it's not going to be that fantastic, because if you want to have a better accuracy, you need to have more data. And obviously, there's not a lot of data in this data set, but it is a multiple target data set. So it gives you an idea of how to work with multiple targets. So the first thing we do is we import our libraries. We imported Pandas, NumPy, Matplotlib, and Seaborn to start out with. NumPy is a mathematical library, and Pandas is a library where you work with data frames. Pandas is made on the back of NumPy. Matplotlib is a graphic library, and Seaborn is a little bit more complicated graphic library, and Seaborn is made on the back of Matplotlib. Now what we're going to do is we're going to read the file. We're reading the file directly off of the sklearn library. So from sklearn datasets, import load Linnerrud. XY equals load Linnerrud, return XY. So it gives you your X variables, but when it gives you your X variables, it gives it to you in an array, and it doesn't label the columns. And it gives you your Y variables. It gives you an array, and it does not label the columns. And what this does is this does not allow you to really analyze the data. That's one of the problems that you have with the sklearn data sets that are provided with sklearn, because these data sets are just already divided into X and Y. And as a result of that, you don't really have an opportunity to perform an analysis. And one of the things that you need to do as a data scientist is to actually analyze the data. And that's something that's not easily done when they've done most of the work for you. So what I did was I created a data frame from the data. And when I created the data frame from the data, I made my columns weight, waist, and pulse, so you can see the data frame that I created. That was data frame 1. I created a data frame number 2, which is your target. And that was chins, sit-ups, and jumps. So now what we've done is we've merged the two data sets. Now what we want to do is we want to check information on this one data set that we have created, and you can find that all of those are floats. And because all of those are floats, it means that there's not going to be anything that's going to need to be encoded. And now what we do is we describe the data set, so you can get some of the statistics on the description of the data set. We check for null values. In this data set, there's not any null values, so that means that there's not going to be anything to impute. And that is one detraction of the data sets that are actually in the sklearn library, because there's not any null values to impute, so you don't get to experiment imputing with null values. And it does a lot of things for you, which if you're studying data science, you're not going to have the opportunity to do those things, because those things have been done for you already. So we don't have any, in this instance, we don't have any null values to impute. Then what we did was we did a heat map, and when we've done the heat map, If you like heat maps, then it can show you the correspondence between the independent variables and the dependent variables. So your independent variables are going to be the 3 columns in your X data set, and your dependent variables are going to be the 3 columns in the Y data set. So really, the idea is that the better fitness that these men are in, the more exercises they're going to be able to do. So now we're going to do the analytics, and so we're going to study the chins. So this is a diagram of the chins, and you can see max chins was 247, min chins was 138, and median was 176. The highest was 154, highest incident was 154, and the lowest incident was 191. So now we check our setups. So the maximum setups was 46, the minimum setups was 31, and the medium setups was 35. The highest incidence of setups was 33, and the lowest incidence of setups was 31. Then we check jumps. So the maximum jumps was 74, minimum jumps was 46, and medium jumps was 55. The highest incidence of jumps was 56, and the lowest incidence of jumps was 58. Now what we want to do is we're going to check the X variable. So we're going to check the weight. And I'm not sure exactly how they did this. I don't know if they did it in stones, or I'm not sure how they did it, because the problem that we have with this particular data set is because they didn't actually label the columns. They just told you what the labels were, that you have to label the columns according to what they told you they were and hope for the best. So that's what I'm doing. I'm hoping for the best. So the max weight is 17, min weight is 1, and medium weight is 11.5. The highest incident was 12.0, and the lowest incident was 5. And now what we do is we check our waist measurements. Again, as I said, because that's another problem with this sklearn data set, is because they don't actually label the columns for you. You have to try to figure out what did they mean. And so what I did was, because I labeled the columns in the order in which they said the columns were, and hoping for the best. So the max waist is 251, the min waist is 50, the median waist is 122. The highest incidence was 101, and the lowest incidence was 162. And now what we're going to do is we're going to check the pulse. The max pulse was 250, the min pulse was 25, and the median pulse was 54. The highest incidence of pulses was 60, and the lowest incidence of pulses was 115. So now what we're going to do is we're going to define our X and our Y variables. So your Y variable is your target, so it's going to be chins, setups, and jumps. And your X variable is your independent variables. It's going to be weight, waist, and pulse. So here's your X data frame in accordance with what they said when they described the data set. And here's your Y data frame in accordance with what they said when they described the data set. So again, we just have to hope for the best. So we've normalized our data. X equals X minus X min over X max minus X min. When you normalize the data, then what you're doing is you're taking the data and you're converting it to a value between 0 and 1, because the model works better if it's normalized. So we've normalized all of our data. And what I did is I standardized the data as well, because what happens is when you are working on data sets, you should normalize and standardize them. Try it with normalized to see what values you get, and try it with standardized and see what values you get. And then what happens is you need to select the methodology that gives you the most accurate reading. And so I did that, and I got the best score with normalized. So that means that I didn't use standardized. And since I didn't use standardized, I just put remarks in all of them so it wouldn't go through. I got less accuracy with standardized than I did with normalized. And standardized is different from normalized, because what standardized does is they take the median value and they make it a 0, and they do it like a bell curve. They do your values like a bell curve. So your median value is 0, and then so all the values less than the median is going to go on the negative side, and all of the values higher than the median is going to go on the positive side. So that's what happens when you standardize your data, and I think it's called Gaussian. So now, after we have normalized our data, we want to split the X data set up for training and validating. And I decided in this instance to use a 20% test size. Wanted to define the model, and because this is a multi-output regression, we had to import a multi-output regressor from sklearn, and I decided to use Ridge, which I actually got that from sklearn. I was going to try to use something else really, but sklearn used Ridge, and I just thought, well, if sklearn is using Ridge, I'll go ahead and use Ridge as well. I only got a 25% accuracy on that, but I predicted on the validation set, and I got a mean squared error, and I got a 131. And when I did the standardized, when I tested this on standardized, I had a higher error. So that's why I decided to use normalized. Now we've got our graphics. We made a graph of the first column of the target, and so you can see there's your graphics, there's your Y-pred and your Y-val. So you can see the Y-val is the blue line, and the Y-pred are the dots outside the blue line. That was for column number 0. And this is the chart that it's made. The chart doesn't look very well, does it? This is the diagram for column number 1. Again, you can see that Y-val is the blue line, and your Y-pred is the red dots, and that's for column number 1. And this is the diagram that it's made, and you can see it doesn't look very good. And this is for column number 2. Your Y-val is your blue line, and your Y-pred are your red dots. And that's the diagram that it's made. So you can see it's not a great data set. It only had 20 values in the complete data set. But even though it only had 20 values in the complete data set, it was enough to give you a little bit of experience in a multi-output frame, which I guess that's why sklearn put it in there. And so that's it. That concludes this code review. If you like my video, please like, subscribe, and share. If you want to keep receiving videos that I have made, then please tap the bell button next to the subscribe button, and you will receive a notification whenever I've made a video. And if you like the work I do and you want to support me, I've got my email address to my PayPal account in the description box below. And the reason why is because I don't have enough subscribers to monetize, which is why I have to ask for donations. So that concludes this video. Thank you so much for watching my video, and I look forward to making more videos for you in the future.